Unlike physical resources like food or fuel, information has a unique economic property. It is non-rivalrous. You can copy a piece of software infinitely at zero or negligible cost without ever using it up. Because of this reality, programmers rarely write common web features from scratch. Every website requires functions like an email login or a cookie banner. There's rarely a reason to manually write that code for every new project. Instead, developers rely on software libraries. These are standardized packages of open-source code that function as replicators, instantly distributing a common action across millions of different internet frameworks. Relying on these replicators allowed developers to scale the modern internet with incredible speed. We built massively complex systems by snapping together pre-made blocks of code, but that convenience hid a deep structural flaw in the architecture. Importing a library means loading thousands of lines of inactive code, causing severe bloat. Worse, libraries rely on others, creating a tangled dependency hell. Since developers can't read all this buried code, one hidden exploit instantly compromises thousands of connected projects. Despite these severe risks, product managers continually mandate the use of open-source libraries. If a manager orders a team to write custom code and it gets hacked, they take the blame. Using a standardized library provides a professional shield against accountability when breaches inevitably happen. We are left with an internet suffocating under its own weight. The software industry desperately needs a mechanism to replicate code at scale without inheriting the massive bloat, fragility, and security hazards of the current system. Large language models offer a potential exit. These systems were built by analyzing millions of open-source repositories across platforms like GitHub, absorbing decades of human programming logic. By digesting this vast archive, the LLM became an advanced, generalized replicator. It can reproduce functional logic on a scale that traditional software libraries could never match. Yet, if you ask an LLM to build a website today, its immediate instinct is to reach out and fetch those exact same heavy traditional libraries. The AI defaults to this behavior because it learned its methodology from its pre-AI training data. It studied millions of legacy projects, where calling open-source libraries was the only efficient method. This optimization curve illustrates the paradox. Using revolutionary AI to retrieve outdated libraries traps development in a local minimum. But LLMs isolate the abstract pattern. Distilling pure logic across multiple libraries, the AI writes targeted code from scratch, bypassing the bulky library entirely. This targeted approach produces immediate architectural benefits. A customized software build contains zero inactive bloat, and it completely severs the brittle dependency tree that drags down traditional projects. It also creates a massive security advantage. Since the AI generates the code uniquely for your specific project, bad actors can no longer rely on known vulnerabilities in standardized libraries to launch mass-scale attacks against your servers. Generating native code through an LLM removes these massive attack vectors. It serves as a structural cure for some of the deepest, most persistent vulnerabilities plaguing the internet today. To implement this cure, developers must intervene. We have to explicitly instruct the AI to burn the extra computational tokens required to write code completely from scratch. The primary tool for this intervention is a skills file. These are straightforward, plain text documents submitted directly alongside the developer's initial prompt. Inside these files, developers issue clear, binding instructions, explicitly forbidding the language model from leaning on traditional open-source libraries. These skills files act as libraries 2.0. Unlike the old system packed with thousands of lines of hidden, unread code, skills files are concise, written in plain English, and inherently transparent for any developer to audit. Embracing this transition triggers a massive shedding of the digital deadweight accumulated over decades. We are stripping away the complex, rusted layers of old internet infrastructure to get back to clean logic. By recognizing large language models as the ultimate replicators, we keep the incredible speed of modern software development while finally curing our systems of dependency hell.